Hi everyone, today we're going to be solving Aqa GCSE Chemistry Higher Tier Paper 2. In this particular video, we're solving June 2021. This one is a part 2 of the question paper where we're going to be solving from question number 6 to question number 10. This question is about cycloalkenes. Cycloalkenes are ring-shaped hydrocarbon molecules containing double carbon-carbon bond. Cycloalkenes react in a similar way to alkenes. Describe a test for the double carbon-carbon bond in cycloalkene molecules. Give the result of the test. So first of all, we're going to talk about the test. Since cycloalkene consists of a carbon-carbon double bond, so we can test it by adding bromine water. And the result will be the color of the bromine water, which is orange, it will become colorless. Table 3 shows the name and the formula of 3 cycloalkenes. Cyclobutene, cyclopentene, and cyclohexane is given. Determine the general formula for cycloalkenes. So we are going to look into the number of carbon. There are 6 carbon. So we can say Cn, and then the number of hydrogen is twice the number -2. Figure 6 shows displayed structural formula of cyclohexane. Chlorine reacts with cyclohexane to produce a compound with formula C6H10Cl2. Complete figure 7 to show the displayed formula of C6H10Cl2. So we're going to draw a single bond between all of the carbon, and then we're going to put chlorine, and we will draw the remainder of the bonds in all of the molecule such that all of the carbon has 4 bonds. Calculate the percentage by mass of chlorine in a molecule of C6H10Cl2. So first of all, we're going to find out the MR of C6H10Cl2, which is going to be 153. Then we are going to find out the percentage of chlorine, which is equals to 71 divided by 153 times 100. So the total molecule, the chlorine has a percentage mass of 46.4. Potash alum is a chemical compound. The formula potash alum is KAlSO42. Give a test to identify the group 1 metal ion in potash alum. You should include the result of the test. To test for potassium, we can perform a flame test, and the color will be lilac. Name one instrumental method that could identify the group 1 metal ion and show the concentration of the ion in a solution of potassium alum. We can perform a flame emission spectroscopy to identify the potassium. A student identifies the other metal ion in potassium alum. The student tests a solution of potassium alum by adding sodium hydroxide solution until a change is seen. Give the result of this test. So when sodium hydroxide is added, aluminium ion reacts with sodium hydroxide and produce a white precipitate. This test gives the same result for several metal ions. What additional step is needed so that the other metal ion in potassium alum can be identified? Give the result for the additional step. We can add excess sodium hydroxide solution. Only if the metal is aluminium ion, Al3 plus ion, then excess sodium hydroxide will cause the white precipitate to dissolve. Describe a test to identify the presence of sulfate ion in a solution of potassium alum. Give the result of the test. To test for sulfate ion, we can add hydrochloric acid followed by barium chloride solution, and then this will give us white precipitate if sulfate is present. This question is about copper and alloys of copper. Solders are alloys used to join metals together. Some solders contain copper. So solder A, mixture of tin, copper, lead, and then solder B and solder C is given, but they have different melting points. Solders B and solder C are now used more frequently than solder A for health reasons. Suggest one reason why. Lead is toxic, so avoiding lead is better. Suggest one reason why solders B and C have different melting points. Even though solders B and C contains the same mixture of metal, however, they may have the mixture in different proportion. As a result, they will have different melting point. Copper can be obtained by processing copper ores, recycling scrap copper. Suggest 3 reasons why recycling scrap copper is more suitable way of obtaining copper than processing copper ores. When recycling is done, it conserves the copper ores because copper ores are finite resource. Recycling uses less amount of energy, and recycling also reduces waste. And the more we recycle, the lesser we will have to quarry or mine that particular ore, which means there will be lesser environmental impacts. Copper is extracted from low-grade ores by phytomining. Describe how copper is extracted from low-grade ores by phytomining. Phytomining is a process of growing plants on land that contains copper ores, and then the plants are burned to produce the ash. The ash is then dissolved in acid to produce a solution of copper compound, and then by using electrolysis of that particular solution, we can then extract the copper, or we can use a displacement of copper from a solution containing copper compound and using a reactive metal, for example zinc or magnesium. Phytomining has not been widely used to extract copper. Suggest two reasons why. Since high-grade ores are still available, there is not enough amount of land available for doing the phytomining. And phytomining takes a long period of time and it's a relatively new technology. A student investigated how a change in concentration affects the rate of reaction between zinc powder and sulfuric acid. So zinc solid is reacted with sulfuric acid to produce zinc sulfate and hydrogen as a gas. 450 cm cube of sulfuric acid of concentration 0.05 mole per dm cube into a conical flask. Add 0.2 grams of zinc powder to the conical flask. Put the stopper in the conical flask. Measure the volume of gas collected every 30 seconds for 5 minutes. Repeat steps 1 to 4 with sulfuric acid of concentration 0.1 mole per dm cube. Figure 8 shows the setup of the apparatus. The student made an error in setting up the apparatus in figure 8. What error did the student make? Well, the student made an error of putting the delivery tube inside the acid. The student corrected the error. Figure 9 shows the student's result. 0.05 mole per dm cube sulfuric acid and 0.1 mole per dm cube sulfuric acid. We can see that it produces different volumes of hydrogen at the end of the process. Explain why the lines of best fit on figure 9 becomes horizontal. So as the reaction continues, after a certain amount of time, the reaction stops because all of the reactant or one of the reactant is totally used up. How does figure 9 show that zinc powder reacts more slowly with 0.05 mole per dm cube sulfuric acid than 0.1 mole per dm cube sulfuric acid? If we look into the particular diagram, we will see that the line for 0.05 mole per dm cube sulfuric acid is less steep. Determine the rate of the reaction for 0.05 mole per dm cube sulfuric acid at 80 seconds. Show your working on figure 9 and give your answer to two significant figures. To do this particular answer, we'll have to draw a tangent at 80 seconds on 0.05 mole per dm cube curve. And then we will find out the value for the x step and the y step, and then we will determine the rate, which is equals to the value of the y step divided by the value of the x step, and thereby we will get the rate, which is technically the gradient. The activation energy for the reaction between zinc and sulfuric acid is lowered if a solution containing metal ion is added. What is the most likely formula of the metal ions added? In order to decrease activation energy, we need catalyst, and we know transition metals are the best catalyst. So only copper is a transition metal here. This question is about alkenes and alcohols. Ethene is an alkene product produced from large hydrocarbon molecules. Large hydrocarbon molecules are obtained from crude oil by fractional distillation. Name the process used to produce ethene from large hydrocarbon molecules. In order to produce small molecule from large hydrocarbon molecule, we'll have to do a particular process called steam cracking or catalytic cracking. Describe the condition used to produce ethene from a large hydrocarbon molecule. In order to produce small molecule from large hydrocarbon molecule, and specifically ethene, we will require a very high temperature. For example, a temperature of at least 600-700 degrees Celsius. And we can either use steam as a catalyst, or we can use catalyst like aluminum oxide. Ethanol can be produced from ethene and steam. So ethene reacted with steam produces ethanol in a reversible reaction. The forward reaction is exothermic. That means the backward reaction will be endothermic. Explain how the condition for this reaction should be chosen to produce ethanol as economically as possible. To produce ethanol as economically as possible, we must use a higher temperature so that it can give a higher rate. Because at higher temperature, the rate of collisions are more frequent, and we can use high pressure because at high pressure there are more frequent collisions, and we can use a catalyst because a catalyst gives a higher rate by reducing activation energy. And now in order to increase the yield, a higher temperature should not be used because it's going to give a lower yield since this is an exothermic reaction. However, a higher pressure will give a higher yield, so a higher pressure is favored because on the right hand side we have, in the product side we have less number of molecules. Now the other factors that we should take into consideration is that high temperature and higher pressure comes with a cost associated with it. So it will increase the cost of production. A higher pressure requires stronger reaction vessels and thereby it cost more. Now we need to choose a compromise temperature, and the reason why we choose a temperature which is a compromise between rate and yield, and also we need to take into the factor for cost. So a pressure which is also a compromise between the rate and the cost is also used, and also the yield is taken into account when considering the cost and when considering the pressure and temperature. Ethanol can be also produced from sugar solution by adding yeast. Name this process. So this process is called fermentation. Butanol can be produced from sugar solution by adding bacteria. Sugar solution is broken down in similar way by bacteria and by yeast. Suggest the reaction condition needed to produce butanol from sugar solution by adding bacteria. So yeast and bacteria work similarly. So both bacteria and yeast requires a warm and anaerobic condition. Ethanol and butanol can be used as fuels for car. A car needs an average of 1.95 kilojoule of energy to travel 1 meter. Ethanol has an energy content of 1300 kilojoules per mole. Calculate the number of moles of ethanol needed by the car to travel 200 kilometers. So first of all, we'll convert the 200 kilometer into meters, which is 200,000. Then we will write the number of moles, which is 200,000 multiplied by 1.95 divided by 1300, and that will give us the total number of moles, which is 300 mole. When butanol is burnt in a car engine, complete combustion takes place. Write a balanced equation for the combustion of butanol. We do not need to use state symbols. So first of all, butanol has a general formula of C4H9OH, that we will burn it in presence of oxygen to produce carbon dioxide and water. Now since there are 4 carbon in the left hand side, we'll produce 4 carbon dioxide, and since there are 9 plus 1 10 hydrogens, so we're going to produce 5 H2O. Now we need to count the number of oxygen on the right hand side. So 4 times 2 plus 5, so 8 plus 5 is equals to 13 oxygen. In the left hand side, we have 1 oxygen with the butanol. So along with it, we will require another 12 oxygen. So we will write 6 O2, which gives 12 oxygen. Guys, that's the end for this particular question paper. Thank you for watching the video. Guys, see you in the next video. Best of luck with the exam. Bye-bye.